Today I have started a quick course of the actual University of Harvard itself about artificial intelligence. And I must say, just from my first reaction, it's a great um, set of classes. And even though I watched just the first one, this is 2 hours long, just the first one. And my mind has been blown already. I would recommend, and it's free, it's totally free. I'm gonna put in the description, though I'm not sure if you can actually enter anymore. Not sure though. So if you can try it out, especially if you have any curiosity or want to enter the market of artificial intelligence. And as just began the course, like the first 30 minutes, I must say my mind was blown because many of things it explains deeply of how artificial intelligence understands what's going on, and so that's what I want to talk about. And interest in a very interesting aspect that it's pretty much like a video game or a game in general with the states and actions. Now, what is a state? Well, first, let's imagine a tic-tac-toe, a simple game of tic-tac-toe. You can win the game by having horizontal, a horizontal, a vertical, and a diagonal line that must be comprised of three of your own points or your own actions per se. I would say it's probably points, not points, but marks. So it needs to be your 3 marks and you need to win. Now, what are the states? Well, the states is pretty much a frame of time or a frame of something, really, that, well, has a set of values. It sounds weird at first, and I'm not even sure if it would make much sense, but it's more like to visualize. I'm going to show you. A state would be every time someone does an action, for example. Every time you put a marker itself, it's a new state. So the state itself is the values that are in the currently in the game. So, for example, let's suppose my artificial intelligence put right at top right, my opponent put right at the middle, and my artificial intelligence put like right at the left, from the left down position. In, well, very interesting indeed. And this would be state. I state would be every time the game changes, every time I make a mark, it would be a new state. So instead, it just has a set of values, a set of marks there is, for example, in tic-tac-toe. It could be any other thing. If you are trying to do a simulation, it could be, for example, a simulation of the the textile resistance of textile resistances. It could be, for example, a state before it was tested. For example, let's say ripped apart, and another state after it was ripped apart, and the set of values that it has within it. So it can be really anything. It could be very detailed. It could be very simple. Depends on what well data it's getting, and so what information it's getting. And because of that, there is the initial state. The initial state is not exactly, for example, in the tic-tac-toe example, it's not exactly when the game is clean, but it's before the game is, well, taking action upon. So, what do I mean by that? I mean that, well, in a game of tic-tac-toe, or in the case in an initial state, it's just a state before the artificial intelligence has any action. It can't be in the middle of the process. If you have an artificial intelligence just in the case of when you commit a crash, just like in the exact split second. I don't know when you would have it. It would probably be useless because usually the best way of to survive a car crash is not having the first place. But let's suppose it has just at handing when exactly crashes. That's the initial state. The artificial intelligence didn't do nothing, but an action is already in place. I mean, the surrounding actions. But the artificial intelligence has a set of action itself. If you think about the tic-tac-toe example, an action would be to put a mark, to put an X on a little circle on it. And it does a set of action to try to go to its goal. Now, a goal could be a lot of things. It can be the goal of that you're upon, but usually we call this the solution. Now, we call the goal or the goal text or maybe the goal state. It's well the last the last state that the artificial intelligence has. So after all of its actions. So let's go through a process here. I have game of tic tac toe. I am in my first state or my initial state before my artificial intelligence has taken any action at all. I want to win. Let's yeah, let's not even put an enemy here. I just want to win, just to make a straight line. So the first action it is to, let's say, put at the middle, and I create another state with that. Not necessarily, but well, usually you take a state every action, or maybe not usually. Now I since I didn't have experience, it didn't actually for what I didn't watch the whole 2 hours, but this is pretty much I watched the first 1 hour about. So you don't need to take states every time, but usually helps because you have more information about it. But let's suppose in my case I take every action. After every action, I take a state. So I have the first state, initial state. My second state after I put in the middle of my action of putting in the middle. My third state of putting the another point in the right middle and then at the left middle. Now I reach my goal or my goal test or again my goal state. Now the goal state doesn't exactly means it's right, but it can actually be called a final state because it's a state after all of the actions have been well made. So after all my actions, I need to see if I found a solution. So what they call a solution here is kind of different. Usually we think solution of well something that finishes, but here the actual use would be, and I quote it here, a sequence of actions that leads from the initial state to a goal state. So isolation would be well all of this process the solution. So from the initial state to the goal or the final state, this is my solution. Of course, it's called a solution if it's actually right, but well, here we are kind of considering that yes. Also, we need to consider that the difference between states and action, not the difference, sorry, but there is kind of a way it needs to understand what it does. Then this is a projection model. Projection model returns the state resulting from performing action A in state S. Pretty much being I create a new state every time you do an action. Uh, I'm not sure if it's necessarily this case, is you need to take a new state every time you do a new action, but it will make sense since there's no way other way to guide it, or well, it's easier to guide at least. So let's go through it again, but now with this whole set of information pretty much. I have my initial state, which is the state before my artificial intelligence did anything, and every single action, which is me playing the game or putting the circles, for example, is an action. And every time I do an action, considering the transition model, I will return the state resulting from action A into state A. pretty much meaning I create a new state after uh, my action, and usually you can compare that. So what was different here? Since I put here in the middle, that means I just need to have, for example, it means that I used one of my dots. I don't have exactly expected amount, but it could have. So I have put one dot, and now I just need two to complete my whole game, for example. And with that, I try to by step, go to my go action, and my go action, my go state or my go test is the last result. It means the last state after all my actions have been taken. In all my actions, and now this process is called solution. Now you actually need to consider a path cost. After all, since you're not specifying well how many dots, you can just fill the entire thing. So you can put one here, for example, one on the left middle, on the middle, on the top right, can place on the top left, place another. You can just fill the whole thing. I don't need to complete. You can just see it by itself. Um, and well, let me see. It will take some time. And there is a necessary action. You need three actions, and these three actions would be an optional solution, or the solution that has the lowest path cost. And path cost means the numerical cost, or pretty much what I did. It can be financially, for example. If I'm trying to build a cell phone, for example, I don't want it to be made out of gold. Neither does I need 64 gigabytes of RAM. I don't need neither, and I also don't think you could actually fit it 64 gigabytes of RAM. But that's a discussion to another day. Um, so I just, for example, I path cost again is the cost that comes to when you take action. So it can be financial, it can be just by time itself. So after all, you take more time to complete all these actions that are unnecessary. And the lowest path cost possible is called the optimal solution, as where you took the least amount of action to make to get to the solution itself, to the goal pretty much. And that's pretty much a little bit of, well, let's say, nomenclature. And all of this is called a search problems. So it has an issue state, and there has to be taken actions to. You need to consider the transitional model, which considers that every action you take creates a new state that is altered from the initial state because of your actions. Then I have my goal test or my goal state, which is the last state after all of what I did, and I need to have a function that is the path cost to determine if what did it cost, what did it take, and usually the path cost is extremely important, like everything else here, but it's extremely important the path cost because usually when you want to do something faster, let's say, for example, again, let's say you're trying to make artificial intelligence design patterns to make textile stronger. I'm not sure why the fixation here, but just for simplicity. I have this little tub of paper. I just take for this, so it's a little bit bruised. But let's say I want to design an artificial intelligence to make it stronger, not with the material itself. No, let's not even put that away. I want to make it stronger, just stronger. Um, and well, the artificial intelligence comes up to a solution that costs $1 billion. That needs to create special machinery, have extremely difficult to find, costly materials, well, to make paper itself or any other material stronger. Now, I don't want to spend $1 billion on it. I definitely couldn't have spent $1 million on it. So I would try to redo again, but now I wanted to have a lower path cost. So I tried to I inputted the information pretty much to try to tell the artificial intelligence, well, take less action, or this path cost is too high, lower it until it finds me a solution that is affordable, that may not, of course, be the best, be, well, better, though not exactly. It means it's worse. Because after all, if you don't have a path cost, it can do extreme amounts of actions to do a simple thing. So it's not exactly because you're gonna spend less that you're actually getting something worse. It can actually be the contrary, just getting something better. So, well, that's kind of the gist of it, I would say. Very interesting indeed. I will try to put a visual representation, so I hope I can put it that way. I'm new to Premiere, but well, I definitely hope you like it. And if you did, and if you're curious about artificial intelligence in general, well, subscribe and hit the notification bell then, because well, I'm gonna have a lot of videos about that in the future. And not just that, but again, remember, the course is free. It is on the description, but I'm not sure you can actually enter anymore. I hope you can, because I think it's very worthwhile. So that's it for today. I hope you like it, and if you did, like and again subscribe for more content like this. Tomorrow I will have more things. I probably explain about notes which I actually learned, but I think it would be too big of a video to state to show it. And I try to show a lot of things like this with visual representation. I'm going to try to do this a visual representation. So I hope you like that. Again, if you did, subscribe. And well, that's pretty much it for today. Hope you like it, and well, see you tomorrow. Bye!